Hello everybody, today we are going to be proving that the limit as x approaches 3 of the function x squared minus 4 equals 5. So, to do this we're going to have to know a definition, so let's write this down. So, definition, and this, we're going to be doing this today using something called the Epsilon-Delta definition of a limit. So let's write this down for you to see. So the limit as x approaches a of f of x equals L if. So what does this mean? Well, the limit as x approaches a of f of x equals L means that for all epsilon greater than 0 there exists a delta greater than 0 such that for all x in the real numbers with the distance between x and a greater than 0 less than delta, we have, what do we have? Well, we have that the distance between f of x, the function, and L, what it converges to, is small. How small? Less than epsilon. Okay, so that's the definition of a limit. So now we're just going to do the proof. But first we need to do some scratch work. This is where we find our delta, okay? This is the most important part of the proof, if you ask me. So what we're going to do here is, we're going to say that, well, let epsilon be greater than 0. And what do we have? We have the distance between x and a is less than delta. So what's a here? A is 3. So let's write this down. Distance between x and 3 is less than delta. And we're trying to get to the distance between f of x, which is x squared minus 4. Let's write that down. F of x minus L, which is 5. Okay, and we want this to be less than epsilon. So let's go through it. So let's simplify this down a little bit. So this equals x squared minus 9. This is quite nice because we can factor this into x minus 3 and x plus 3. Sorry, let's put that there. So, with this, well, we have our delta here, x minus 3, less than delta. We have that, very nice. And we want this to be less than epsilon, but we can't have our delta in terms of x. So we need to sort something out of this guy, okay? Well, let's draw a little picture first. So, let's go down a little bit. So we have this here, okay? 1, this is just real numbers, 1, 2, 3, 4. So x minus 3, the distance between x and 3. So x is going to be around here, okay? X. So the distance, well, think about this. This is 1. This is 1. So the distance between x and 3 is going to be less than 1 when delta is equal to 1. Adding 3 to this, well, first of all, let's say that, well, this means that x minus 3 is less than minus 1, sorry, greater than minus 1, and less than 1. Adding 6 to each side, because we want to get something with x plus 3, because that's what we need, okay? So adding 6, we get minus 1 plus 6 is 5. X minus 3 plus 6, x plus 3, very nice, less than 1 plus 6 is 7. So we have that the absolute value of x plus 3 is less than 7. And that's very nice. So I'm actually running out of room here. So let's try squeeze this in up here. Sorry. So this equals, actually no, this is less than. Okay, so x minus 3, so that's less than delta. And x plus 3 is less than 7. And this is our epsilon. So delta is going to be what? It's going to be epsilon over 7. Okay, so now we have our delta. So we have that delta, let's write this down, equals the minimum, because we want to find the minimum of, and we used 1, so it's going to be 1, and epsilon over 7. Okay, so we have that. Now we are running out of space here, so I'm just gonna rub some of this out to make some room. Okay, so let's get rid of some of this. Right, so next what we're going to do is we're just going to sort of formalize all this into our proof. Okay, so we're going to say let epsilon be greater than 0, choose delta to be what we found, which was the minimum of 1 and epsilon over 7. And then we're just going to go through. Okay, we start with x squared minus 9 because that's what we have, and we show that that's less than epsilon. Okay, that's the goal. That's what we're trying to do here. So nearly got rid of all of this, and now let's do it. Okay, so we're going to say proof. Okay, this is the proof part. Okay, there we go. So proof. So now let's just get straight into it. So we have let epsilon be greater than 0, choose delta to be what we found, which was the minimum of what? Of 1 and epsilon over 7. Okay, 7, that's a 7, guys. So now we're just going to say, so we've done this, and we're going to say such that for all x in the real numbers, this is our definition. Yes, for all x in the real numbers with the distance between x minus 3 less than delta, we have x squared minus 9, because that's just our function, minus L, x squared minus 9, which equals x plus 3, x minus 3. And now we want to go back to what we had earlier. So we said that, well, hold on, x plus 3, well, we know that x minus 3 is less than delta. Sorry, the absolute value of x minus 3 is less than delta, which we're saying is the minimum of 1 and epsilon over 7. So this is less than 1, greater than minus 1, while we are running out of space. Adding 6, we get that x plus 3 is greater than 5 and less than 7. So the absolute value of x plus 3 is less than 7. So now we can use this. We get that this is less than 7 delta. Delta is going to be epsilon over 7. This equals 7 times epsilon over 7, which equals epsilon. And that is our proof today. So hope you enjoyed this video, maybe learnt something new today, and please leave a like and subscribe for more.